inversion. Let me see this topic today now. I want to today I will try to finish the topic now, but if it's possible, I will take tomorrow also. Now is the recording is going on now?
Yes, sir.
Yes, sir.
Now let me see. First of all, already you know, chiral center is nothing but what actually a carbon having different groups around it actually, right? The carbon is having different group around it. Just a minute, lost. So we'll see what today enantiomer. So based on that chiral center, let me see enantiomer now. Now enantiomer means what? Generally, when you observe a definition here, non-superimposable mirror images. Generally, they are called actually, isn't it? Enantiomers, isn't it? Let me see some example here. What is that enantiomer? Generally, what is the meaning of enantiomer? It's very simple. Non-superimposable mirror images. Non-superimposable mirror images. Mirror images. These are called actually what? Enantiomers. In examination, you may get a definition like this. What is enantiomer? Give a suitable example here. Now, the definition we can see non-superimposable mirror images generally called actually what? Enantiomers here. Now, what is the meaning of non-superimposable mirror images? Now, all of you put your right hand on left hand. Please put your right hand, left hand, or right hand on left hand. What you observe in that case, let me see now. When you put your, isn't it, your right hand on left hand, what happens? Do they are superimposable or non-superimposable? If you put like this, what happens? This is your left hand. You are keeping your right hand like this. Now, do they are superimposable, non-superimposable? Tell me now.
Non-superimposable.
This is not called non-superimposable. This is called what? Superimposable. If you place your hand like this, isn't it? This is called what? Superimposable. Now, what I'm saying, non-superimposable. See, this is non-superimposable here. So this is the thumb, isn't it? This is the left, the thumb, and your right thumb. Both are not getting superimposable here. See, this is on right, left side, and this one is what on right side, isn't it? This one is on right side, not superimposable, and this one is not superimposable, isn't it? So if I put like this, what happened? This is called what? Non-superimposable. This one is called what? Superimposable. Like this. This is called what? Superimposable. Now, enantiomers are non-superimposable like this. Now, mirror images means like this. If you put your hand like on the what we call mirror, you will get mirror images like this in this way, isn't it? So, non-superimposable mirror images, isn't it? Put like this. Non-superimposable and what here? Mirror image. For this, it will be a mirror image like this. I will show by using some example here like this. So you got the definition, very simple, non-superimposable mirror images. Okay, let me see this one with an example here. You observe this diagram here, this one. You observe this part, if you observe here, this part. This part, if you observe here, what happened? These hands are what actually non-superimposable and mirror images here. If you observe this part actually here, this part, if you observe what happened, these are actually non-superimposable mirror images here. This part, non-superimposable mirror image, non-superimposable mirror image. Then they are called what? Enantiomers, isn't it? Generally, what happens? Chiral objects will give this type of enantiomeric nature. Okay, the chiral molecules generally exhibit the enantiomeric nature. You observe this one here, these two, if you see observe. Now, these are called, of course, superimposable mirror images. You see, they are called superimposable mirror images. These are not called what? Enantiomers. Now, these are actually enantiomers. So, which are called enantiomers? Non-superimposable. This is there in the textbook. You observe the textbook, non-superimposable mirror images are called, isn't it? Enantiomers. Isn't it? They are called what? Enantiomers here. Okay. Now, superimposable mirror images are not called what? Enantiomers. Isn't it? So, this point you need to remember here. Now, we'll take one example here. We'll take one example in this slide. We'll take an example. I'm taking here what? Carbon. Just a minute. Carbon, CH3, chlorine, CH2, CH3. Now here it is having something CH2, CH2, CH3. Now this is called what? Star mark I'm writing. Star indicates it is asymmetric center or chiral center. Now why it is chiral center? Because it is having all four groups, if you observe, chlorine, methyl, ethyl, and what? Propyl. These are what? All groups around, isn't it? All groups around carbon are different. Around carbon are different. Therefore, this is called what? Isn't it? This is called what? Chiral molecule. This is called what? Chiral molecule or asymmetric center. And this exhibit what? Enantiomeric nature. This will exhibit enantiomeric nature actually. Enantiomeric nature. Okay. Now, if you observe this one, I will take a beautiful example for this one. I am putting here what? OH. Here what? Hydrogen. Here what? CH3. And here I am putting what here? COOH. Now, is it called chiral molecule or not? Tell me. Is it called chiral molecule or not? This one. This is lactic acid. The name of this one is called what? Lactic acid. Okay. Now tell me whether it is chiral or not. Anybody?
So it's chiral
Whether it is,
compound, sir.
is my voice is not audible for you?
So it's audible.
It is getting late for you.
Yes, sir.
Okay. Now this is chiral center. Now how to write enantiomer here? Now I am taking one more here. Same molecule I am taking one more. Now if I write something what here? Just carbon, hydrogen, OH, and what? COOH. Now it is also called lactic acid. Both are what? Lactic acid. Now, and these two are mirror images or not? Tell me first of all. Do these are called mirror images? Do these called mirror images?
Yes, sir.
Yes, sir.
Definitely they are called mirror images only. If you put one of the molecule, any one molecule here, and mirror what happened, this will be its yes, just okay. This part, if you observe what happened, this hydrogen and this hydrogen, this thing you have to observe. Now these are what? First of all, mirror images. Okay. Now do they superimposable? Now for example, if I put what happened, this lactic acid over here, this if I put over here like this, okay, methyl group will superimposable. COOH will be superimposable. Now what about on hydrogen? What will come? Tell me.
OH.
OH. On OH, what will come?
H. Hydrogen.
H. That means totally it is non-superimposable, right? Totally it is what actually non-superimposable mirror image here. So definitely lactic acid is called what? Enantiomer. Okay. Now if I write something like this, shall we take what one more slide in this case? Now if I write something like this, today we are getting some problem, I think, starting with you. If I take something what? OH, hydrogen, and here I am taking CS3, and here I am taking also CS3, right? Now, CS3, hydrogen, OH, and CS3. Now, in this case, what happened? These are actually mirror images, right? These also what? Mirror images. Correct or not? Do they are mirror images or not? These two.
Yes, sir.
Do they are non-superimposable or superimposable? Non-superimposable or superimposable?
Non-superimposable.
Non-superimposable. Now here also they are mirror images and non-superimposable, but these are not at all called what? Enantiomers. You can't call this one what? Enantiomer. And these two are same only. There is no difference between these two. Both are what? Same only. Why? Because it is not having the chiral center. See, this is having what? Same groups here. Now, what is the condition for enantiomer? Generally, what happened? The carbon must be a chiral center. The condition must be here what actually chiral center here. Condition is what? The carbon should have at least one. That means in the molecule, total molecule, at least one carbon should have chiral center. At least one carbon should have chiral center. Then only they exhibit this type of optical activity. Now see optical activity. I will explain this. Now if you observe this one here, if you place this one in the plain polarized light, that means monochromatic light, the light which is having one direction. Okay. In that case, what happened? The polarimeter will move maybe clockwise like this. The light will move in the form of clockwise like this. That can be, if it is moving clockwise direction, the name we are giving for that one will be dextro. D for what actually? Dextro we are giving. It can also taken as positive sign also. Positive sign or small d or dextro we are giving here. Now, if you put the molecule, if it is what rotating in anti-clockwise, that means whatever the plane polarized light is rotating towards anti-clockwise like this, in that case, you are going to have LEVO, small l or LEVO rotatory or minus sign we can give. Now, this one, isn't it, is having minus sign and this one having what? Plus sign. That means based on OH we are not saying. Okay. So by seeing the OH, it is what dextro here. For example, here in the OH on right hand side. To me, it is a right hand side. Okay. In this case, the OH is what? On left hand side, right? In this case, the OH is on left hand side. By seeing this left hand side OH, you can't say it is levo. By seeing the OH on right hand side, you can't say it is dextro. That can be explained by only what? Experimentally, by using plain polarized light or polarometer. If you place this molecule in polarometer, the plain polarized light, if it is moving in clockwise direction, that can be called as dextro. Otherwise, it can be called as levo here. Okay. So this is experimental phenomena. So identifying the dextro molecule and levo molecule is purely what happened? Experimental phenomena, right? Now, these two are collectively called what? Anybody? These two are collectively. If you do any reaction, if you get 50% of dextro and 50% of levo, collectively they are called, tell me. Collectively they are called
Racemic mixture.
Racemic mixture.
racemic mixture. Okay. Now, for example, what happens here? We'll take one more slide here. For example, I've taken like this. Carbon, bromine. Here I've taken something CH3. You have taken hydrogen, something what? COOH. Now doing something what? Aqueous KOH. I have taken something aqueous KOH here. So I got something, even adding some water also, H3O plus 1. So this is something extra I'm taking here. CH3, carbon, I got here OH, correct or not? Shall I get OH or not? In the place of bromine, shall I get OH or not? Correct or not? Tell me. Yes. In the place of bromine,
Yes,
shall I get
sir.
OH or not? Because it's which type of reaction? Tell me it is. Which type of reaction it is? SN1 or SN2? नहीं, डिहाइड्रोहैलोजिनेशन कैसे होता है? So what we are discussing? Nucleophilic substitution reaction. SN1 होता है, SN2 होता है. Is it SN1 or SN2? Yesterday only I have given homework also for you.
SN2, sir.
SN2.
कैसे हो जाएगा SN2? आपको रात वो आकर बताया आपको. What we have discussed actually, tertiary dominantly undergo SN1, secondary dominantly undergo SN2. Now this carbon is actually what happened, isn't it? Bonded to two carbons only. Okay, this is bonded to two carbons only. So in this case, what happened? I have taken some water here. H3O plus means I have taken some water, means what? Polar solvent I have taken. So when you take a polar solvent, yesterday I told you, dominantly it will undergo SN1 mechanism. So in the place of bromine, what happened? We are going to get the OH. So here what I mean to say is that, do we get two products or one product? Tell me. In this case, we get two products. Two or one? Speak loud. Two products. Why? Because in SN1 reaction, if the reactant is chiral center, yes, this reactant is what actually chiral center. This carbon is what actually chiral center. So when you have chiral center in the SN2, SN1 reaction, definitely you are going to get racemic mixture. So in this case, one will be dextro, other will be levo. One will be plus, other will be minus. So we are going to get the racemic mixture. Racemic mixture we are going to get. We are going to get racemic mixture. Now here what I mean to say in this one, this process is called what? Racemization process. Racemization process. Now tell me what is the meaning, anybody? What is the definition of racemization? Can you say? What is the meaning of racemization? Can you say? By seeing this reaction, is it possible for you?
Process by which we can get racemic mixture.
And your voice is what? Not clear.
Conversion of enantiomers to racemic mixture.
Conversion of an enantiomer into what? A racemic mixture is called what actually? Racemization. So you may get a question from this one. What is the definition of racemization? Give with a suitable example. If they ask what happened, you have to give this definition. Conversion of enantiomer, isn't it? Enantiomer into what? A racemic mixture, plus and minus. This is nothing but called racemic mixture. It may be plus or it may be minus. Okay, it may be plus. This enantiomer may be plus or it may be what? Minus. That means converting plus into, isn't it? Plus and minus, or converting minus into plus and minus. This is nothing but called actually racemization. Very simple definition or not? Conversion of an enantiomer into a racemic mixture is called what? Racemization. So you can give any example like this. You can take this example, with that you can explain. Okay. Next we'll move to what? One more topic. We have seen one thing in SN2 mechanism. We got some product actually, right? We got a product in this SN2 mechanism. Tell me what is the meaning of SN2? That means what is the product we got in SN2 reaction? Which product we got? We have written something there. Can you say that one? Which product we got? Yesterday only we discussed, no? See, remember, when you come to class, please again watch that video, isn't it? Please, otherwise read the textbook what we completed yesterday. For example, today we are discussing about the enantiomers, everything. So before coming tomorrow class, what happened? You need to read that. You can't sit in the classroom like you are sitting cinema theater, without any prior preparation. We sit in cinema theater. Otherwise, without any prior preparation, we see YouTube videos, movies like that. Like that, you can't sit in class. So when you are sitting in any class, what happened? You need to read what we completed yesterday. Yesterday we completed what actually? SN1, SN2. So compulsory you have to read textbook. Now see, in SN2 we are going to get Walden inversion product. So we are going to get an inversion of product. In SN1 we got racemic mixture. Okay. In SN2 reaction, we are going to get here Walden inversion product. Now, what is this Walden inversion product here? Let me see this one, Walden inversion. So yesterday we have taken one example. So again, let me see this example one more time. For example, I have taken something here, CH3. Here I have taken what? Bromine. Here I have taken something what actually a hydrogen here. Here something I have taken a deuterium. Just imagine that. Okay. Now this one I am treating with aqueous KOH. Now definitely, surely this I have taken some non-polar solvent also. I have taken something, a non-polar solvent, something which is called CS2 something, which is a non-polar solvent. I have taken non-polarities. Benzene or anything you can take which is not developing any charges, whose dipole moment is what? 0. Right? Now this is what? Which type of alkyl halide? Tell me. Which type of alkyl halide? आपका जवाब के पहले मैं मार्केट जाकर वेजिटेबल भी परचेस कर सकता हूं. इतना देर आप दे रहे हैं.
Sir, tertiary.
Yes.
Primary.
Primary, secondary. Huh?
Sir, tertiary.
Primary.
Primary. Some is saying something
Primary.
tertiary. This carbon bonded to how many carbons here? Only one carbon it is bonded. So it is primary. So surely it will be SN2 mechanism. Now is it chiral center or not? This carbon is chiral center or not? Tell me. Yes or no? Yes, it's
Yes.
chiral center. See, all are different groups only. No, one is bromine, one is methyl, other is hydrogen, other is deuterium. So इतने सोचने की बात भी नहीं है इसमें. So definitely it is a chiral center, right? So definitely we get inversion of product. If it is not center, if it is not chiral center, we don't get any inversion product. Normal product. Even in SN1 also we get a normal product. इसमें डिस्कशन करने की जरूरत नहीं है. किसमें डिस्कशन करना है आपको? जिसमें chiral center है. उसमें आपको डिस्कशन करना है. इन्वर्शन प्रोडक्ट आएगा, रेसिमिक मिक्सचर आएगा, नहीं तो एक ही प्रोडक्ट आएगा, उसमें कोई रेसिमिक मिक्सचर नहीं होगा, ना तो इन्वर्शन का प्रोडक्ट भी नहीं होगा. सिर्फ chiral सेंटर में सभी होगा. ठीक है ना? तो what we are discussing here, inversion. How to get inversion product? Tell me how many products we get in this one? Tell me how many products we get? Yesterday class we discussed this one.
Sir, 1.
Yes.
1.
Only one product that will be, isn't it? That will be definitely what happened like this. This you are calling as inversion product. Walden is a scientist name. So you need to write that one. Simply we call inversion of product. Now why you are saying inversion of product? That we discuss now. There will be two things will be there. One is called retention of product. Retention of product. Other is called what? Inversion of product. Now let me see now here what is the meaning of retention and inversion. How we get this? Now again I am writing this part here. CH3 bromine deuterium, and here I am writing what? Hydrogen, right? Now tell me, around the carbon there are 4 different groups are there, and which group is having, that means whichever group is directly bonded to carbon, highest atomic number. Tell me which one is having highest atomic number, which is directly bonded to carbon, the chiral center.
Bromine.
Bromine atomic number is called 35. So this you take as a first priority. Okay, whichever group, whichever element directly bonded to chiral center, which is having what? Highest atomic number, that is what? Highest priority, first priority given. Next, remaining 3, second priority given to, for which group?
Methyl.
Methyl, because this carbon bonded to carbon atomic number is what? 6 now. Now the priority will be 2 here. Next, after hydrogen deuterium. Now which we have to give priority? Because both are having what here? Atomic number of hydrogen, how much here? Atomic number of hydrogen, how much here?
1.
1. Atomic number of deuterium?
1.
Sir, 1.
Atomic number of 1. Now when both are having atomic number is equal to 1, now you have to see the mass number. Now compare the mass number. Hydrogen mass number will be
1.
1.
what about deuterium mass number?
2.
2, right?
2.
Number of hydrogen, deuterium same. That is the reason. Now consider the mass number in which deuterium D is having more mass number. Mass number of deuterium will be 2 and mass number of hydrogen will be 1. Therefore, the third priority we have to give. Now leave it the fourth priority. You can no need to write the fourth because remaining will be definitely fourth. No. If I say what happened, first ranks to what last rank, I'm saying last rank, no need to say that one because the last person will be definitely last rank one, right? So here no need to write the fourth priority. Now what we have to do, take, now go from 1 to what? 2. Now 2 to what here? 3. Now is it called clockwise direction or anti-clockwise direction?
Anti-clockwise. Anti-clockwise.
Clock or anti? Anti or clock?
Anti.
Anti.
If you have any doubt, you just imagine the watch. If you imagine the watch, you will get this one. Definitely, this will be the clockwise. definitely it will be the clockwise. If it is clockwise, isn't it? I'm writing here. If you have something clockwise direction, if it is clockwise direction, what sign we have to give? What sign we have to give here? The sign we need to give R configuration we need to give here. The configuration will be R. If it is anti-clockwise direction, this will be anti-clock, sorry. If it is anti-clockwise direction, if it is anti-clock, the configuration we are giving is S configuration. So when it is clockwise, what we have to give here? R configuration. When it is anti-clockwise, you have to give S configuration. Now, which configuration you have to give for this one? Anti-clockwise?
S.
But here we are giving what here? R configuration I am giving. Why? Rule is actually when you observe anti-clock will be S only. But here anti-clockwise, but still I am giving R configuration. What is the reason? See. Now, what is the fourth priority? Tell me here. Where is the fourth priority is there? And which group fourth priority is there?
Hydrogen.
On hydrogen. Now, the fourth priority, whatever it may be, fourth priority in horizontal or vertical line? Horizontal means what? Like this. Vertical means what? Like this. Okay, understood? No. Now tell me the fourth priority is on horizontal or vertical line?
Horizontal.
Horizontal. See, this is having in horizontal like this. This is called horizontal row, we call this one. So in that case, what happen? R becomes S, S become R actually. Okay. So what you have to see, this is the note very important. Generally, not useful for you, but in textbook they given retention of configuration. That is the reason I'm explaining this. Otherwise, it will be useful in the NEET examination most probably. What happened? See. So simple discussion only I will complete here. So note, if fourth priority, isn't it? If fourth priority on horizontal line, okay. Now R will convert into S. If it is R, take as S. If it is S, take as what? R. So this is the principle compulsory you have to remember. Clockwise for R, anti-clockwise for S. But if fourth priority is on horizontal line, R becomes S, S becomes R actually. So that is the reason I have taken R. Okay. Now what I am doing here, if I take here aqueous KOH, okay, aqueous KOH, what we are going to get? OH on left hand side, and here we are going to get CS3, and here going to something what happened? That hydrogen, and you are going to get the deuterium something. This you are going to get, right? Now again you give configuration for this one. What type of configuration you are going to get? R or S configuration? Tell me now. Which will get higher priority in this case? Which group will get highest priority among these four? It's a chiral center. Which part will get? Which part will get high? Which part? I didn't understand what is
OH.
OH. इतने सोचने की जरूरत नहीं इसमें. ओके, सोच लो. तो फर्स्ट प्रायोरिटी है, सेकेंड प्रायोरिटी ये है. दिस विल बी द थर्ड प्रायोरिटी. ओके, नाउ it is moving like this. Now it is clockwise or anti-clockwise?
Clockwise.
Now clockwise actually we need to give R configuration, but fourth priority is on horizontal. Fourth priority on horizontal. So what we have to go for this one? R will convert into here. Yes. In all cases, you don't need to convert. Only if the fourth priority is on horizontal, we need to convert like. Now this is having what? S configuration. Now this is having what? S configuration. Now this phenomena you are calling retention, sorry, inversion of configuration. You are calling this one what? Inversion of configuration. Inversion of configuration we need to call. Understood here? Now what is inversion of configuration? The reactions in which the configuration of that molecule what happened changes from R to S or S to R. They are called what? Inversion of configuration. In some cases what happened? Configuration do not change. They are called what? Retention of configuration. Now, where we get retention of configuration? Can you say where we get retention of configuration? Is it possible for you? Where we get retention of configuration? Is it possible for you? Where we get retention of configuration? Is it possible? Now, if you observe here what happened, give the again configurations for this one. Now, this is the first priority. Second priority we need to give here. You observe here. Here carbon is there. Is it visible for you? Here carbon is there. Next to the carbon, you are having hydrogen here, right? Correct or not? Next to the carbon, you are having hydrogen. Next to the carbon, you are having hydrogen or oxygen. Next to the carbon, you are having hydrogen or oxygen.
Oxygen.
Oxygen. So that is the reason, if both the case, here you are having carbon and here also you are having the carbon. In that case, what we have to do, we have to take next element. If next element is having more atomic number, that will have more priority. In this case, the next element is what? Oxygen. In this case, the next element is called hydrogen here. So that is the reason what I am saying, this will be the second priority and this will be the third priority. So here it is which direction here? 1 to 2, 2 to 3 clockwise direction. But horizontal rule is there. Horizontal rule is there. So clockwise actually should be taken as R, but I am taking this one as S configuration because of horizontal rule. Okay. Now, after we got some products here, after when we got a products here, so again, this will be the first priority. This one will be the second priority. This one will be the third priority. So here also we are going to get clockwise direction R, but again, the fourth priority is on horizontal. Therefore, R is converting into S configuration. Next, if you observe, first priority, second priority. Next, what happened? Third priority. Here it is what? Anti-clockwise direction. We need to take actually yes, but again isn't it? Again, what you are having here? Horizontal rule is there. Because of horizontal rule, isn't it? Because of horizontal rule, what I am taking here? Give it this. No. Because of horizontal rule, I am taking this R configuration. Okay. Of course, it's S configuration anti-clockwise. Because of horizontal rule, I have taken what happened here. Now, conversion in the racemic. This is a racemic mixture. This is a racemic mixture. Definitely, this is SN1 mechanism. Now, conversion of S into S. This is called what? Retention of configuration. Retention. Okay. Next, converting S into what? R. Converting S into R is what called? Inversion of configuration. Inversion of configuration. Now, I am concluding here in SN1 mechanism, if reactant is chiral center, the product is what? Racemic mixture. We are going to get two products equally. One is retention product and other is surely what happened? Inversion of product. But in SN2 mechanism, we get Walden inversion product. If reactant is chiral center, we get what? Walden inversion of product. Only one product, and that is what? Inversion of configuration. Understood? This retention configuration and inversion of configuration, how we are giving the priorities? Based on atomic numbers. If atomic numbers are same, go for the mass number. If atomic numbers are same only and mass number also same, what you have to do? Next element you have to consider. Next element, whichever is having highest atomic number, that will be the highest priority. Understood here? In examination, they don't ask right what happened RS configurations here, because that is not there in the syllabus. But syllabus you are having retention, inversion of configuration is there. That is the reason we explain. In the NEET examination, they may ask this type of questions.
Sir, please teach this again.
Yes. Bolo beta.
Sir, repeat this.
What I have to repeat? Your name.
No, sir. Sir, about anti-clockwise and clockwise. All about that.
एंटी-क्लॉकवाइज एंड क्लॉकवाइज. देखो बेटा, अगर आपका आप वॉच कैसे होता है बेटा? 3, 6, 9 ऐसा होता है. वॉच कैसे घूमता है? ऐसा 12 से 3 आ जाएगा, 6 से 9 ऐसा आ जाए तो इसको बोलेंगे क्लॉकवाइज. वी कॉल दिस वन एज व्हाट? क्लॉकवाइज, राइट? सो अगर आपके पास ऐसा वॉच है, जैसे मैं दिखाता हूँ, आपका पास ऐसा वॉच है 12 से 9, 6 से 3 होता है, ऐसा आपके पास ऐसा वॉच है आपके घर में? नहीं है ना?
No, sir.
तो इसको क्या, एंटी क्लैक, एंटी मीन्स opposite to the clockwise, isn't it? Opposite to the clockwise. Now if it is, that means for example you observe here 1, then you have to go 2, after 2 leave it the fourth parity, next go for what, 3 here. So this direction if you observe, it looks like clockwise only, so I have taken clockwise actually for what, R configuration, but I have taken S because the fourth priority is on horizontal line, ऐसा है horizontal line में, तो R will convert into S. Now if you observe this one, first parity, right? First parity, now moving to what, second parity, next what happened, third. Now this looks what actually anti-clockwise. Just imagine the clock here, anti-clockwise. For anti-clockwise generally you have to take S only, but here also the fourth parity on horizontal. If the fourth parity is, for example, if the fourth parity is here like this, just imagine. Now in this case no need to change the rule here. Okay, I will show one more example, that one. Okay, now in this case the hydrogen, the fourth parity is on horizontal line, now S will convert into R, right? Now I will take one more example here. I will take one more example. See here, if you write like this here, carbon, okay, OH, deuterium, COOH. Now I am writing here hydrogen. Now first parity, second parity, third parity. Now this one will be the fourth parity. Now 1 to 2. This is what, clockwise. This is what here, clockwise. So which configuration we have to give here? Which configuration we have to give here?
R.
Configuration we have to give. Which configuration we have to give? R configuration we have to give. R, we no need to change. Why? Because the fourth parity is on vertical line. See, this hydrogen is not horizontal, it is on vertical. This line it is having. This is having vertical line here. So for vertical line, no need to change the signs here. No need to change it. For this one, if you observe what happened here, 1, 2, 3. Now definitely this will be what actually, clockwise only. Now in this case, R configuration must be converted into S configuration. What is the reason? What is the reason why? Because hydrogen, the fourth priority on which line here? Horizontal line. Horizontal line. Understood? That whatever the fourth priority is on horizontal line, now convert R into S here. But fourth priority is on vertical line, no need to convert this one. This is a rule actually. So we have to follow this rule when you are giving the configurations. Understood? So even though if you don't understood, listen this class one more time after the class. You watch on YouTube. Okay, you will get that one. Okay. So now you got what is the meaning of retention configurations, what about the racemic mixture, everything you got now. Now we'll do one thing actually. These some reactions, let me see. Some of the reactions are there. Let me see some reactions here. I think this slide already we discussed in the last previous videos. Okay, I'll start from this one. Already we have discussed here nucleophilic substitution reactions, the last class. Now let me see here what happened. Each and everything. First one, if I take first one. Okay, if alkyl halide on reacting with aqueous KOH, the product must be what actually? In the place of X, what we get here? OH here. Correct or not? In the place of X, we are going to get the OH. Alcohols we are getting. With the byproduct, KX will be removed. That is what? Different. Next, if I take what? Moisture silver oxide. Ag2O, silver oxide. Moisture silver oxide means what actually? Ag2O. It is not Ag2O. Moist silver oxide means Ag2O. Moist means nothing but what here? Water. Now both are reacting to give silver hydroxide. If I take a 2 moles here, we get definitely 2 moles. Moles are not important. Now actually, if they say moist silver oxide, now what we have to take? Actually, AgOH we have to take. If they say what happened? Moist silver oxide. What we have to take actually? AgOH we have to take. That is the meaning here. AgOH. Now again, OH will replace over the X to convert into what here? ROH. Again, we are going to get alcohol. One more reagent is the dry silver oxide, Ag2O, that I will explain in ether topic. In ether topic, I will explain this one. Here I will see only, we'll take only what actually? Moist silver oxide only. When moist silver oxide is given, you need to take what actually? Silver hydroxide we need to take. In which what happened? OH, isn't it? OH will convert into what here? That means OH will replace X, isn't it? To give what here? Alcohols. Understood? Are you having any doubts regarding aqueous KOH and moist silver oxide to give the products here? How to write the product here? For example, CH3, CH2, Br, moist silver oxide, moist silver oxide. Tell me the product name here. What is the name of the product? Tell me. Common name or IUPAC name, whatever it means. Tell me the product name. Do fast. Moist silver oxide.
Ethanol.
Ethanol or ethyl alcohol. Both are what? Correct only, right?
Ethanol.
Next, generally useful in the conversions only. In examination, they ask what? Convert ethyl chloride into ethyl alcohol. You have to take what? Either what? Aqueous KOH, what? Moist silver. They don't ask in this easy, but they will ask some 2-3 conversions like that. Okay, next. Third one, let me take. Third one. These are all are what? Whatever we are discussing, all which type of reactions? Nucleophile substitution reactions. In the third one, nucleophile substitution reaction, I have taken ammonia, generally called often ammonolysis reaction. Now, what happens here? In the place of X, what we get here? NH2 we get here. In the place of what? This one we have to take excess. Otherwise, if you take excess, what happens? You may get what actually tertiary, secondary amines we are going to get. That will discuss in the last chapter. How we get if you take excessive. So just remember here alkyl halides must be excessive. How the reaction takes place if you observe what happened. I have taken what happened? CH3, CH2, Br I have taken. In the place of R, what I have taken? CH3, ethyl group I have taken. Simple thing. Ammonia I am writing like this. Hydrogen N. Shall I write like this ammonia? Is it correct or not? Tell me first of all. Is it correct of writing of ammonia? Any wrong is there in this? Any mistake is there here? Writing ammonia like this? Any mistake is there or not?
No, sir.
No. Correct only. For making a mechanism, I have written like. Now remove the HBr here. Now add this NH2 over on the carbon here. Now what we get here? CH3, CH2, NH2. Isn't it? This we are going to get. In the place of R, you see, this is R actually. So we got RNH2, primary amine. So I want to get primary amine. So what I have to do? I have to take excess of alkyl halide. This part, if I take excess, what happen? I will get primary amines. What is primary amine? Just like what primary alkyl halide, same thing, same type of definitions. Okay. Now, secondary amine, if you want tertiary amine, you have to take ammonia is excess. If you take excess of ammonia, you will get secondary and tertiary. That will discuss in the nitrogen compounds. Okay. The third one is also completed. Next, we will move to what? Fourth one. Sodium alkoxide. If I take what? Sodium alkoxide. So generally this reaction is Williamson synthesis reaction will comes in ethers. So when we discuss ether topic, will come that one. But anyhow, we will see this reaction. Again, alkyl halide. Okay, the reactant in all cases same only. The reactant is same. We are taking different reagent only. So we are getting ether actually. How we are getting ether? You see, I have taken methyl chloride. This methyl chloride, shall I write like this? Instead of writing like this, I will write CH3Cl plus. Write reversely. This one, sodium ethoxide, you write like this, sodium ethoxide, C2H5. This will be R group. You can take any R group here. You can take any R group here. Okay. Now NaCl will be removed and you join this one here. So here also we are going to get CH3O C2H5. This is called ether, isn't it? Ethyl, methyl, ether, or methoxyethane, isn't it? The name of this one is called meth. This part is meth, no, meth, oxy, and this is having 2 carbons called as ethane here. Okay, methoxyethane or ethyl methyl ether. This is called Williamson synthesis reaction. Very, very important neighbor reaction, but this we discuss in ethers again, no problem, right? Next, we'll move to what? Next, another reaction, 5th one, with KCN. With KCN, with AgCN, 2 things will be there. Now, this is very, very important. All of you observe carefully. Everyone must observe this one. KCN, if I take, when alkyl halide is treating with KCN, we are going to get either cyanates, or we can also call the cyanide, also one more name is there, nitrile. The compound we are going to get nitrile. For example, if I take something like this, I've taken something CH3Br, treat with KCN, what we are going to get? Methyl cyanide, CH3CN plus KBr. Okay, this is called what? Methyl cyanide, which is actually what? Common name. Methyl cyanide is common name. What is IUPAC name? See, 2 carbons are there. Ethane, nitrile we have to call. This is called what? IUPAC name. So if you want these nomenclatures, you just see your notebooks of 11th class, it will be there actually. Clearly I have explained there in the 11th class nomenclature. You search on your notebooks, it will be there. So what is happening? Again, KBr is what? Removed. So this part is attacking on the carbon. Understood or not? Methyl cyanide. Okay. Now, for example, if I take this one, tell me the product name. Is it possible for you? CH3CH2, isn't it? Chlorine, treating with what? KCN. Now tell me what is the product here? What is the product here? Name of yes?
Ethyl cyanide.
Cyanide. Ethyl cyanide. Okay, whichever the carbon, this carbon is bonded to chlorine, no. So that carbon will get the, see, many of the students, they write like this because they don't have mind, no. So they write like this, isn't it? They write something what? CN, they put CN here. Okay, is it correct? No. Which carbon should get the cyanide here? The halogen carbon. The halogen bonded carbon will get the nucleophile. The nucleophile attacks on the halogen bonded carbon, not here. Understood here? अगर आपका brain नहीं है तो, isn't it? सबके पास mind होता है मगर brain इतना ज़्यादा चलाक नहीं होते हैं ना, तो वो लोग क्या करते हैं यहाँ पर attach करते हैं. ठीक है ना? तो ये आपको देखना है. एग्जाम में देखता हूं ऐसा बहुत सारे आंसर्स आएगा. तो इसका नाम क्या है? इथाइल साइनेट, और इसका IUPAC nomenclature is called propane nitrate because 3 carbons are there. Propane nitrate. Okay, so you have to write this everything on your notebook. So only simply watching complete आज का क्लास हो गया, देखेंगे कल, ऐसा नहीं होना चाहिए. Afternoon, if you want to watch video again, you watch that one and make notes of that. When I think from November, December, definitely schools will reopen, 100% reopen. So I will check every notebook and all your practical marks will be based on your notebooks only. And your exams will be starts by March only. Yesterday we got news also. So they are starting exams early. Even they start exam before March also. So that is the reason what happened. All of you ready for examinations. ऐसा अभी वीडियो देखकर ये आफ्टरनून बाहर जाना ऐसा छोड़ दो. After watching every videos, whatever it may be, you have to make note, watch again. That is the reason I am recording here. वो यूज के लिए मैं रिकॉर्डिंग नहीं कर रहा हूं यहाँ पर. Right. Next we'll see what AgCN. Now if I take AgCN in the place of KCN, if I take AgCN, this is very, very important in examination point of view. If I take AgCN, you observe you got isocyanate. The name of nomenclature here, isocyanate. Reverse R. See, we are getting some functional isomers we are getting. So for example, if I take what happens, CH3, CH2, Br reacting with AgCN. Now, isn't it? CH3, CH2, NC, NC. This is called what? Ethyl isocyanate. This is called what? This group is called what? Ethyl group, no? Ethyl isocyanate. Ethyl isocyanate. So, say, again I am writing it. CH3, here I am writing CH3, CH2Br on reacting with KCN, okay, on reacting with AgCN. Okay, same reactant with different reagents are giving different product. Here we are getting what? Cyanates. Here we are getting what here? Cyanates. And here we are getting here what? Isocyanates. This is the thing. One you are getting cyanates, other you are getting what? Isocyanates. Now remember, this looks what very simple. इतना आसान है ऑर्गेनिक केमिस्ट्री, बहुत इजी है ना. अगर आप KCN लिए तो साइनाइड आ जाएगा, अगर AgCN लिए तो आइसोसाइनाइड आ जाएगा. मगर important thing is that it is not remember for examination. When it comes in examination, what happened? You can't recollect this. That is the main point. If it is easy, what happened? Remembering is what? Very difficult. If it is hard, what happened? We can remember for long time. So organic chemistry, you have to practice like this. By writing the nomenclatures, what happened? It will be easy for you. Don't write what happened simple that structures. That is not correct. Along with nomenclature, if you practice what happened, with less practice, it will be remembered for up to exam. Okay. KCN is giving what? Cyanates. AgCN is giving isocyanates. Why? Because KCN is ionic compound attacks from the carbon side, where AgCN is having covalent character attacking from nitrogen side, because you can't break the bond here. Because being as a covalent bond, what happened? It is impossible, difficult to break the bond here. So attacks takes place from the nitrogen side. Therefore, what we are going to get? Isocyanate. But being as ionic compound, we can cut this one here. So carbon side, what happened? We can attack, right? So AgCN, KCN, you have to remember that. Next, we will do what? One more nucleophilic substitution reaction. Carbylamine also we can give the nomenclature. Carbylamine also we can give that one. Okay, right. Silver carboxylate. If I take what? Silver carboxylate, all are there in the textbook in a box. They given everything. So after this class, what happened? You go through that box given in the textbook. So if I take what? Carboxylate, silver carboxylate, the compound we are going to get the esters here. That means you see what we are doing, different alkyl halides are converting into different products here. Okay, now we can convert alkyl halide into what? Esters. Let me see this one. Now what happens here? We are going to get this product. This is the product we are going to get. Now I will make this one very simple for you. In the place of R, what I am taking here? CS3. In the place of X, what I am taking here? Cl. You can take even chlorine, you can take chlorine or bromine, you can take. Okay. Now I am writing reversely this one like this. For your understanding, I have taken reversely like this. Go. In the place of R, I have taken C2H5. Otherwise, you write something what I have full nomenclature. CS2CS3. C2H5 is nothing but CS2CS3. Now what happens here? Silver chloride will be removed here. Now we are going to get here CH3, CH2, CS3. But don't write like this. Write reverse. For your understanding, I given like this, but write what happened. Otherwise, you do one thing. First, you take this compound CS3, CH2. Here we need to take what? C. Sorry, you have to take here one more carbon. Again, I am writing this. Just a minute. CH2, CS3. Okay. Here also what we get here? CH2, CS3. In this way we are going to get. So I am doing it like reversely. I am taking COO, CS3. Sorry, Ag. Now this is called what? Silver propanoate. Silver, because 3 carbons are there. Silver propanoate. Silver propanoate. Propanoate. On reacting with ethyl chloride or methyl chloride, right? This one you write reversely. This part you write reversely. To make the product, this one you take reverse part. So chloromethane. So AgCl we remove here. Okay. Now remaining you just join that one. CS3, CH2, COO, CS3. Now this is called what? Methyl. So write down methyl. Now after this, how many carbons are there here? 3 carbons are there. Prop, ane, OH. OH generally we give for nomenclature for ester. Now it is having single bond called as ane. For ester nomenclature will be OH. First you have to call methyl, then this part, propanoate. So the name is called what? Methyl propanoate. So in examination they will ask, if they ask what happened in a conversion, how to convert methyl chloride to methyl propanoate. You see, you have to take this reaction. So that is the reason it is difficult for you. So in the examination, if they ask what happened, how to convert chloromethane into, isn't it, methyl propanoate. Methyl propanoate. You should get an idea which reagent we have to take, isn't it? If we get that idea only, we can do. Otherwise, what happened? We can't do. So this is about the 7th one with silver carboxylate. You take many number of examples. If you are interested what happened, you can take in place of R, you take what ethyl group, propyl group. Here you can take methyl group like that. So based upon this mechanism, we can do the things. Now, with this what happened, all nucleophile substitution reactions are completed. Now let me, give me this answer now, tell me. Give me answer for this question, all of you. I will stop now here. Too fast. What is the correct answer?
Ethyl cyanide.
Ethyl cyanide.
Ethyl cyanide.
Ethyl cyanide option will be A here. Now tell me what is the answer? What is X there asking? Methyl chloride, CS3, Cl, on reacting with what here? X I don't know, we don't know anything. So we got something dimethyl ether plus NaCl. Just now we discussed here Williamson synthesis reaction. We have discussed now. Williamson synthesis just we have discussed here. What is X here? There are. Just now we discussed this one. Now we got extra product is what here? This one only, no? In the place of Cl, what we got? Tell me in the place of Cl, what we got? Methoxy. Now methoxy is there where? Tell me in answer. Where is methoxy group is there?
Sodium methoxide.
हाँ ऐसा आपको करना है, शॉर्टकट से करना है, ऐसा आपको लिखना है रिएक्टेंट और प्रोडक्ट का, ऐसा लिखने के बाद आपको आएगा आंसर. ऐसा सेंटेंस देखे तो नहीं आएगा. You have to make that into structure only. That is the reason I am saying IUPAC nomenclature, common names frequently I am writing. So if you know the IUPAC nomenclatures or common names, what happened, then we can make the structure. Once you make the structure, what happened, we can easily answer the question. So with this, what happened, today class is completed, and tomorrow also, I will take class only tomorrow. Day after tomorrow, I will take. Next week onwards, I don't take daily. Okay, next week. Let me see if we finish. If chapters were not finished, what happened? We see only. We'll take only. Okay. Tomorrow also I will take class at what time? Again 9:30, 10:30. I will try to finish the chapter tomorrow. Okay, tomorrow also very important topics are there. When I started, only 28 are there. Now I got 34. How they added? Just tomorrow onwards, you see what happened. Only I will give extra 10 minutes only. After 10 minutes, don't join in classroom. Still what happened? How many members were absent today? 7 members were absent. Okay, no problem. If you have any doubts, you can stay with me. Otherwise, what happened? You can log out.
Sir, what is R&S configuration?
Which configuration are you asking?
Sir, R&S.
वही आपने कभी बोला ना, मैंने RS nomenclature अभी वही हुआ ना अभी तक.
सर बट सर मतलब उसका मतलब क्या होता है?